Welcome back, everybody. This is part 2 of factoring rules or factoring strategies, whatever I called it. So we did factoring the greatest common factor, factor by grouping. Today we'll do factoring trinomials when the leading coefficient is 1 and when the leading coefficient is bigger than 1. Okay, so these are the steps to factoring a trinomial whose leading coefficient is 1 in the form of x squared plus bx plus c. Look at all these rules. Well, I'm just going to make it simple so we don't have to read through all of this. All we're going to do is, first thing you always want to do is look for a greatest common factor. But then after you do that, what we're going to do is find all the factors of c. So we're going to list c and find all the factors of it. That's what we do right down there. So find all the factors of c, the constant, make a list, and find out which factors add or subtract to become the middle term b. And then once we figure that out, we will then set up the parentheses based on the signs of the trinomial. So this isn't something that's shown here, so I guess I'll write it. So if we have a trinomial of the form x squared plus bx plus c, then in your parentheses you will get plus plus. If we have the form x squared minus bx plus c, then in the parentheses we'll have minus minus. If we are given x squared plus bx minus c, then we can have the form minus plus or plus minus. And if we are given the form x squared minus bx minus c, we will have the same thing above. Plus minus or minus plus. So the factors of the constant c that you see here, let's say it was 24, we list all the factors of 24 and we would have to input them correctly with the correct terms of the trinomial, with the correct signs of the trinomial. So we'll just have that there, and once we do it, to check your work to see if we got it correct, we must FOIL it back out. We don't have to do that all the time, but that's the way we check. So like I said, read all these rules if you want, but I am going to walk you through it on this video. Okay. So let's start with number 1. Okay, so this is a trinomial whose leading coefficient is 1. So these are the only type of trinomials we're going to get for this part of the notes. So if we get this form, then all we have to do is find all the factors of the last number, the constant, 45. Starting with 1 and 45. Does 2 go in there? No. Does 3 go in there? Yes. 3 and 15. Does 4 go in there? No. Does 5 go in there? Yes. 5 and 9. 6, 7, 8, 9. We are done. These are the only factors of 45. Now, to factor it properly, we look at the signs of the trinomial. Plus minus, if you reference that last page, plus minus will factor to plus minus. So this will become parentheses, and what we're going to start with is x. And we're going to have x plus a number and x minus a number. Or it could go the other way. X minus a number, x plus a number. And now what we have to figure out is, out of these 3 factors, which ones, when you add together or subtract together, which of these factors can give us 4? So when I say add and subtract, we'll try it out. If you tried 1 and 45. 1 minus 45 is 44. 1 plus 45 is 46. These are nowhere near 4. So this means these are out. You could even go the other way. 45 minus 1, 45 plus 1, you're still not going to get anywhere near 4. Okay, try the next ones. 3 and 15. Well, 3 minus 15 is negative 12. 3 plus 15 is 18. And like I said, if you could go the other way, 15 minus 3 is 12. 15 plus 3 is 18. Are any of these numbers even close to 4? And again, that answer is no. So this means that 3 and 15 will not work. All right, last numbers to try out. 5 and 9. 5 plus 9, 14. 5 minus 9, negative 4. We're getting really close. That's negative 4. We're looking for positive 4. So what's another way to rewrite it? You could have 9 minus 5, which gives us 4. Ding, 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 ding. That's what we're looking for, right? So this means whatever is going to go inside these parentheses to fill out the last spot, we have to figure out how to put 9 and 5 in there. Well, easy enough. Look at the signs. This 9 is positive. This means that I must put a positive 9 in there. This 5 is negative. This means that when I put 5 in, it must be negative. Another way to say it is, well, between the factors 5 and 9, if 4 is positive, this means the bigger number 9 has to be positive, and the smaller number 5 must be negative. That's the only way you're going to get to positive 4. And guess what? This is completely factored now. That is it. So now, the only way to check our work is to FOIL it. So we're going to say check. And when you FOIL it, x times x, x squared. X times negative 5, negative 5x. 9 times x, positive 9x. 9 times negative 5, negative 45. Put it together and you get x squared plus 4x minus 45. And if we end up with the same exact, if we end up with the same exact polynomial that we have in the beginning problem, then we have factored correctly. That's it. That's all we have to do. That is factoring trinomials. Nothing crazy yet. There we go. Okay, I'll leave all that up for that one. So this is our answer. Now, let's try it again. Can I get rid of that? Nope. I'll just leave it. Okay. All right, let's do it again. W squared minus 15W plus 50. List all the factors of 50 and find the factors that can give us negative 15. Start with 1 and 50, 2 and 25. Does 3 go in there? No. Does 4 go in there? No. Does 5 go in there? Yes. 10 times. Okay, then you go 6, 7, 8, 9, 10. And the reason I don't put 10 in is because we already have that factor. 5 and 10 is the same as 10 and 5. So there's no need for those. These are all the factors of 50. Now we ask ourselves, which of these factors, when added or subtracted together, can get me to negative 15? And you guessed it, it has to be 5 and 10. If you guessed it. I'm just speaking to anybody out there, right? Okay. So now, since we have picked the right factors, we can now go into the factoring process, where we'll start with W. And now, once again, based on the signs of your trinomial is how your signs will go. Once again, reference the other page I had, and minus plus means W minus number times W minus a number. And oh man, our life is easy because we know that the factors of 5 and 10 work. So all we have to do is plug in 5, plug in 10, and guess what? That's done. That's factored. It is done. So that's gone, that's gone. Those won't work. And here is our final answer. Of course, check. And I'll say check. Foil it. You'll get W squared minus 10W minus 5W plus 50. And that'll give us W squared minus 15W plus 50. There it is. This is the exact same as that. So it checks out. But remember, whatever I box is our answer. The green is just checking our work. Okay, not bad. Let's keep going. Three, Z squared minus 16Z plus 48. All right. Let's do it. Let's go down and find all the factors of 48 that could possibly make 16, right? 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5, no, 6, yes, 6 and 8. And these are all the factors of 48. Okay. And if you're like, how do you do that so fast? Well, for you guys, if you do not know all the factors of a number, Google a multiplication chart. It'll make your life a lot easier. So using a multiplication chart will help you find all the factors of any number. Okay. Now, we ask ourselves, out of this list of factors, which factors can make negative 16? 1 and 48 can only make 49 or 47. Out. 1 and 24 can only make 26 or 22. 3 and 16 can only make 19 or 13. 4 and 12. 4 and 12 can make 16, and 4 and 12 can also make 8. So we're looking good there. And then 6 and 8. 6 plus 8 is 14. 6 minus 8 is 2, negative 2. So gone. 4 and 12 is our only answer here. Okay. So now we know the factors that can make 16. I mean, we can even write it out. I can say, because we want negative 16. So to get negative 16, you would have to write this as negative 4 minus 12, giving me negative 16. So negative 4 minus 12, giving me 16, negative 16. Okay, so we go ahead and factor it. And look at your signs. Minus, plus mean minus, minus. So you'll get z minus a number, z minus a number, and lucky for us, the only numbers that go in there are 4 and 12. Okay. Once again, we can check our work. If I FOIL, I get z squared minus 12z minus 4z plus 48. And I get z squared minus 16z plus 48. This all checks out. We get back the original problem. Not bad. Okay, so there is our final answer. Okay, still going. 4, negative 40t minus 30t squared plus 10t cubed. Well, this doesn't look like the trinomial we've been looking for, right? What we've been working with so far is trinomials of the form x squared plus bx plus c, where the highest power is x squared. On this problem given, on this expression, or this trinomial, we're given that the highest power is t cubed. So when you run into a problem like this, the first thing you should look for is a greatest common factor. Can we put this equation into this form? And that answer is yes. Well, hopefully yes. We have to find what the greatest common factor is first. So that's what we're going to go for. GCF. So let's look. Negative 40, negative 30, positive 10. Let's go ahead and take out a 10. And then t squared, t cubed. We can take out a t. That's the GCF. And what we are left with is if I factor out a 10t from negative 40t, so 10t from negative 40t gives me negative 4. 10t from negative 30t squared gives me negative 3t. And then 10t from 10t cubed leaves me with positive t squared. Okay. Now we have taken out the greatest common factor. And what we're going to do next is rewrite it with the highest power first. So I'm just going to rewrite this. Do not forget the greatest common factor on the outside. So 10t. And inside, I'm going to rewrite it highest power first. So t squared minus 3t minus 4. All we did here was rearrange. Rearrange. And now, inside, we have the form that we want. The x squared plus bx plus c. The trinomials we have been factoring on the last couple of examples. Which means, let's go ahead and factor it. Let's make a list of the factors of 4 that can possibly make -3. 1 and 4, 2 and 2. Which of these factors, when added or subtracted together, can make -3? Well, 1 and 4 can make 5 or 3. So this is going to work. 2 and 2 can only make 0 or 4. So those are out. So if I rewrote it to make -3, I would write it as 1 minus 4 to give me -3. And now we can factor it. So look at the signs of this trinomial. Minus minus means plus minus or minus plus. So when we factor this, do not forget the greatest common factor that's on the outside. We must start with 10t and then start our parentheses. We'll say t plus a number and t minus a number. Well, we're already set up for that. Look at your 1 minus 4. The 1 is positive, so this means 1 has to be positive, and the 4 is negative. So this means 4 has to be negative. And guess what? It's factored. That's it. No more. This is our answer. And of course, we can check. I'm not going to distribute the whole thing. I'm just going to distribute this part. Check. You get t squared minus 4t plus 1t minus 4. This will give us t squared minus 3t minus 4. Now, does this look like that? T squared minus 3t minus 4. They both look the same. This checks out. So this means if you decide to distribute the 10t in, you would end up right back here. So we are good. The check checks out, and we can keep going. Okay. Factoring, so much fun, right? Okay. Number 5, negative 5w plus w squared minus 6. So when you see a problem all jumbled up like this, one of our first thoughts should be, let's go ahead and rearrange it from highest power to lowest power. So we should rearrange this as w squared minus 5w minus 6. We just rewrite it. That's it. And now, since it's in the form that we need, all we have to do is find the factors of 6 that can make -5. So 1 and 6, and 2 and 3. All right. Oh boy, well, 1 and 6 can be 1 minus 6, which gives me -5, which is what we're looking for. And also, 2 and 3, if I wrote it as -2 minus 3, that will also give me -5, what we're looking for. Oh boy. So, what do we do here? Well, we have to try them both out. and see which one actually works. So this means we can go ahead and get ready to factor. So for this one, look at your signs again. Minus, minus. Well, this means we're going to have W plus a number, W minus a number. W plus a number, W minus a number. Okay. Well, now this should clear up on what numbers you can use, because once again, reference your signs. Look at my 1 minus 6. Here the 1 is positive, and there the 6 is negative, which matches what we have in our parentheses. Here we have a positive, here we have a negative. This might check out. We have to find out though. So this means that from my 1 minus 6, the 1 is positive and the 6 is negative. Now let's go ahead and FOIL it out and see if we have the right answer. If we don't, this means that we're going to have to try the other factors. So if we check, we're going to get W squared minus 6W plus 1W minus 6, which is going to give us W squared minus 5W minus 6. Now, does this trinomial look like that trinomial? W squared minus 5W minus 6. They look exactly the same, which means this checks out. And this is our answer. So 2 and 3 wouldn't work because, once again, if you reference your signs, 2 is negative and 3 is negative. And our signs are only plus minus, which means 1 has to be positive, 1 has to be negative. So that is one quick way to tell that, hey, 2 and 3 is not going to work out. So 2 and 3, no good. There we go. Okay, all the factoring fun you can handle, right? Okay. 6, negative a squared plus 6a minus 8. Okay, so once again, this is not in the form I want because once again, we want the x squared plus bx plus c. So the way we like to factor is if the leading coefficient of that x squared is a positive 1. We don't like it if it's a negative 1. Well, there's something we can do about it. There's something that we can factor out to fix this. And that happens to be a negative 1. Let's go ahead and factor a negative 1 out. And when I factor a negative 1 out of all 3 of these terms, it's going to change their signs because negative 1 from negative a squared makes positive a squared. Negative 1 from positive 6a makes negative 6a. And negative 1 from negative 8 makes positive 8. And now we have the perfect form because both our leading coefficients are positive 1s. And it's just easier to factor that way. You could definitely factor with a negative in front, but it just doesn't look right and it's probably just harder to go about. So it's better just to make our leading coefficients a positive 1. Just factor that negative out. Okay. And now, since we have put it in its proper form, we take 8 and find all the factors of 8 that can possibly make negative 6. 1 and 8, 2 and 4. Hey, that's it. And 1 and 8 can only make 9 or 7 when added or subtracted together. So, gone. 2 and 4, 2 plus 4 makes 6, and 2 minus 4 makes negative 2. We are looking for 6, which means 2 and 4 is going to work out. So in order to make negative 6, we can write 2 and 4 as negative 2 minus 4, which gives me negative 6. Okay. We are now ready to factor. So once again, when we're factoring, do not forget that we took out a greatest common factor of negative 1. So that must stay out in front. And now in my parentheses, and based on the sign of my trinomials, minus plus means minus minus. We're going to get a minus a number times a minus a number. And guess what those numbers are? 2 and 4. And done. That's it. And if you believe your work enough, there is no reason to check again. But if you need to, go ahead and check. I will save some time in the video by just saying, hey, that's correct. Let's move on. All right, 7. Negative 2c squared minus 22cd minus 60d squared. The first thing that should pop in your brain is that you see a common factor of 2. And not just 2, there is a common factor of negative 2. So that's what we're going to factor out. If I take a negative 2 out, if I factor a negative 2 out, this means I'll get c squared plus 11cd minus, actually plus 30d squared. So all we did was take a negative 2 out and all the signs have changed. And now we look and there are no other greatest common factors in there. You can't factor out a C and you can't factor out a D. So this means we are ready to find all the factors of 30, the final number, the last number. What are all the factors of 30 that could possibly make 11? And just ignore that D squared for now. Don't worry, it'll come in when we factor. 1 and 30, 2 and 15, 3 and 10, 4 no, 5 yes, 5 and 6. And these are all the factors of 30. Now look at it and ask yourself, which of these factors can make 11? 1 and 30, right? 1 and 30 can only make 31 or 29. Gone. 2 and 15 can only make 17 or 13. Gone. 3 and 10 can only make 13 or 7. gone. 5 and 6 can make 11 or -1. I want to say 11 or 1, right? So 5 and 6 is our clear winner, which means if we rewrote it, you would have 5 plus 6 equal to 11. Okay. And now we are ready to factor. So let's go ahead and set up our parentheses. And do not forget that common factor of -2 that you took out. And in my parentheses, let's look at the signs. Plus, plus, hey, that makes our life easy. This means we'll have C plus a number times C plus a number. And guess what those numbers are? +5 and +6. Now here's where the variable of D comes in. We're going to have to rewrite it as 5D plus 6D. And that is our answer, completely factored. Don't believe me? Go ahead and FOIL to check it. There you go. Nothing to it. Okay, keep moving. 8. Same situation as above. -3a squared plus 15ab minus 12b squared. Pop, 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 pop. What should pop in your brain is that you see -3, 15, and 12. You should say that you have a common factor of 3. But since the leading term is negative, we're going to have a common factor of -3. And if I take out a greatest common factor of -3, then I should be left with a squared minus 5ab plus 4b squared. Taking the negative out changes the signs on everything. Negative from negative is positive, negative from positive is negative, negative from negative is positive. 4b squared. Okay. Which means we are in the perfect form and we can find all the factors of 4 that can possibly make -5. 1 and 4, 2 and 2. Well, it's definitely going to be 1 and 4, right? 1 and 4, 1 plus 4 makes 5, or 1 minus 4 makes 3. So we're looking for 5. 2 and 2 can only make 4 or 0. So these are out. Which means in order to get to -5, I have to write my numbers as -1 minus 4, which will give me -5. We are now ready to factor. Don't forget that greatest common factor of -3. And now look at your signs. Negative, positive means minus, minus, where we're going to get a minus a number times a minus a number. And guess what those numbers are? Right there. -1, -4. And since it's a b squared for the variable, we'll have -1b and -4b. Now, you don't need that 1 there. MATLAB might count it off. So it would be best just to write your answer as A minus B times A minus 4B. And there it is. You can check your work by foiling, but I believe in us, okay? Or me, since it's just me here. Okay. A squared negative 4B. Yep, we are good to go. All right. 9. Last one for these type of trinomials. Okay. T to the 4th times u squared plus 6t cubed u squared plus 9t squared u squared. All right. Well, first thing that should pop in our heads is there a greatest common factor? Because there should be. This thing looks crazy, right? So we look at the numbers. There's a 1 in front here. There's 1, 6, 9. Nothing coming out. Then we look at the variables. T to the 4th, t cubed, t squared. The smallest power of t we can take out is t squared. And then we look at u squared, u squared, u squared. We can take out a t squared, u squared. And if I factor that out from the above trinomial, we are going to be left with, let me see, t squared from t to the 4th, u squared is just going to give me t squared plus t squared u squared from 6t cubed u squared is just going to leave me with 6t. And then t squared u squared from 9t squared u squared is just going to leave us with 9. There it is. There's our greatest common factor on the outside. All we want to worry about is factoring the trinomial on the inside. It is in the perfect form that we need. So, factors of 9, 1 and 9, 3 and 3. Which of these factors can make positive 6? 1 and 9, definitely not. 1 and 9 can make 10 or 8. So this is out. 3 and 3 can make 6 or 0. We want 6 and 0. Well, I mean, we just want 6. But so we want 3 and 3. So that's going to work out. And in order to get 6, I can write this as 3 plus 3, which gives me 6. We are now ready to factor. Do not forget the greatest common factor that you took out. And now start your parentheses and look at your signs. Plus plus means plus plus. So we'll get t plus a number times t plus a number. And the factors that go in there are right here. 3 and 3. And that's it. That's done. You could simplify one more step if it asks you to. This answer can be t squared u squared times t plus 3 squared, since we have 2 t plus 3s. Simplify. There we go. All right. That was factoring trinomials where the leading coefficient is 1. Not bad. If there's a greatest common factor, take that greatest common factor out. And then check your work by foiling. Now we get into the good stuff. This is called factoring by the educated guess and test method. So this means now that the leading coefficient of A is now bigger than 1. So when we factor using the guess and test method, now the first step is going to be to list all the factors of the leading coefficient A, and then list all the factors of the leading coefficient C. And then we'll make the signs of our trinomial, of our parentheses, based on the signs of the trinomials. Here is the list that I wrote earlier. Remember, plus plus means plus plus, minus minus means plus minus or minus plus, minus plus means minus minus, and plus minus means plus minus or minus plus. So the signs of the trinomial tell you how to set up your parentheses. And then step 4 is where we practice the guess and test method, because now we want to know what factors are going to work, and we must mix and match until we get it right. So this is where we guess. And that's the learning process. We can get it on one guess. We could get it on 20 guesses, as long as we get it right. So the whole point of the guess and test method is to get you better at multiplying numbers, adding numbers, subtracting numbers in your head, to where when you actually see one of these trinomials to factor, you can be like, I already know how to factor that. I don't have to write anything down. I can just look at it and be like, that's what it is factored. But again, that takes practice. And of course, to check your work, you must FOIL. Okay, so let's get started on everything I just said. Not that we remember it, right? Okay. So now we're factoring these special trinomials, because now we actually have a leading coefficient bigger than 1. And of course, you always want to check for a greatest common factor, but there's nothing here. 6, 19, 10, nothing's coming out. So when dealing with these trinomials, the first thing to do is make a list of all the factors of the leading coefficient. What are the factors of 6? 1 and 6, 2 and 3. Then make a list of all the factors of the constant, the last number. What are the factors of 10? 1 and 10, 2 and 5. Oh boy. Now we will set up our parentheses and see which numbers work. I'll show you how it all works. Okay, so take note, that's plus plus. So this means that we're going to get parentheses plus a number times parentheses plus a number. And here's our first try. So the way the factors work is that the factors of the leading coefficient fill in the first space. The factors of the constant, the number, fill in the last space. I should change color on that. Hang on. So our goal here is to mix and match the factors until we get it right. So this means that we can start with 1 and 6, which means if I start with 1 and 6, I'll get 1x and 6x. And then I have two choices. I can go with 1 and 10, or I can go with 2 and 5. And this is the whole guess and test method. So you'll catch on to a pattern here of what actually works. So let's start with 1 and 10, and let's see what happens. I'll put a 1 here, and I'll put a 10 there. And now the only way to check our work is to FOIL. So check. 6x squared plus 10x plus 6x plus 10. I get 6x squared plus 16x plus 10. And does this look like the original one? And that answer is no. Here we got 16, and we're looking for 19. So this doesn't mean that 1 and 6 and 1 and 10 doesn't work yet, because then there is a simple fix. So this was try number 1, which means we have to move on to try number 2. And one of the easiest fixes is just to switch the numbers around. So what I'm going to do now is make this x plus 10. Actually, I need to fill these in. Hang on. And we'll make this x and 6x. But now we're going to switch the 1 and the 10 around. I'm going to say 10 goes here, and 1 goes there. Okay. And now, once again, you must FOIL. Check your work. 6x squared plus x plus 60x plus 10. We get 6x squared plus 61x plus 10. That is nowhere near the 19 we need in the middle. So what this means is that for 1 and 6, the 1 and 10 is not going to work. So try number 2 is wrong. Which means we go to try number 3. And now, instead of trying 1 and 10, we have to do 1 and 6 and 2 and 5. All right, so 1 and 6 and 2 and 5. So if I do that, and I'll just keep them all the same color now, you'd have x plus, actually I need the factors over there. We'll do x plus 2 and 6x plus 5. And don't worry, I know the answer. I'm just taking you the long route. I'm showing you how guess and test works. You check your work, and you get 6x squared plus 5x plus 12x plus 10. We get 6x squared plus 17x plus 10. Not going to work out. Which means we go to try number 4. And try number 4, we'll just switch the numbers. We now make it x plus 5 and 6x plus 2. FOIL it, and you get 6x squared, and I'll just add the 2 middle terms already. 6x squared, you get 2x plus 30x. You'll get 32x plus 10, and nowhere near it. So this is actual good news, because what this tells us is that 1 and 6 is not going to work. We've exhausted all tries of 1 and 6. So now we must do the same thing for 2 and 3. You're just like, oh, come on. Oh, don't worry. This is the process, though. This is the learning process. Now imagine you keep doing this and you start to get the numbers faster in your head. Boom, boom, boom. They're just coming at lightning speed, which means you no longer have to write down 50 tries. You can get this thing in 1 try. All right. But like I said, I'm showing you the learning process because now we go to try number 5 and we go 2, 3, 1, 10. 2, 3, 1, 10. And you get 2x plus 1 and 3x plus 10. Foil that out. And you'll get 6x squared, that's 20x plus 3. You'll get 23x plus 10. Try number 5 is no good. 6, do it again, just switch the numbers. 2x plus 10 and 3x plus 1. 6x squared plus 2x, you'll get 32x plus 10. Nowhere close. Oh my goodness, but guess what this means? This means that 1 in 10 is officially out. We exhausted all tries on 1 in 10. All that's left is exhausting all the tries on 2 and 5. Okay, now let me erase all of these. We're on try number 7 now. Okay. So this is try number 7. We're going to do 2x plus 2 and 3x plus 5. Foil it. 6x squared, that's 10x plus 6x. You get 16x plus 10. Oh, try number 7 doesn't work out. Try number 8. Flip the numbers. 2x plus 5 and 3x plus 2. Foil and check. 6x squared plus, what is that? 4x and 15x. You get 19x plus 10. Ding, 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 ding. We get it on the 8th try. Does this look like this? And the answer is yes. So, on the 8th try, we get it. Now, this should infuriate you. This should make you angry. This should make you motivated to get it on 1 try. And I can tell you a nice little trick that works 98% of the time. When you're factoring trinomials like these, the factors, the answers that go inside your factors in your parentheses are usually the last 2 factors. Works 98% of the time. Not all the time. Like, why didn't you say that 30 minutes ago? Because that's the learning process. But now, that's a little trick. Like I said, doesn't work all the time, but maybe we can keep trying it. So let's get on with these notes, because that took forever. Okay, here we go. Factors of 12. 1 and 12, 2 and 6, 3 and 4, and then that's it. Those are all the factors of 12. Hey, lucky for us over here, factors of 2, 1 and 2. We are now ready to factor. And look at your signs. Plus minus means plus a number, minus a number. And, well, maybe we try our trick because we only have we have 3 and 4, and we have 1 and 2 down here. So let's try it. Choose these different colors. So Maybe this might work out for us. 3x, 4x, and then I'll put, let's see. And also you have to be smart about your number placement. So I'm gonna put 2 here and 1 there. Why not? And if I FOIL these, I'll get 12x squared minus 3x plus 8x minus 2, giving me 12x squared plus 5x minus 2. Oh my goodness, first try. Look at that. They look exactly the same, and there's our answer. Yep, let's keep going. Sometimes it can be that easy. But once again, let's say the 2 and the 1 didn't work in that position. You just flip the 2 and the 1 like I did on the last examples. So 2 easy fixes. Switch the numbers or switch the signs. All right. 3, same thing. 6, 1 and 6, 2 and 3. 4, 1 and 4, 2 and 2. All right. So let me see. We can try our trick here and see if it works. So let's go ahead and set up to factor. Minus, plus means minus, minus. So you're gonna have minus, minus. So if we try our lovely little trick here, 2 and 3, 2 and 2. Let's see, 4 and 6. I don't think it's gonna work out. But that's the whole point of trying. 2x and 3x, and then all I have are 2 and 2, and that's not gonna work out. One of the reasons I know it's not gonna work out is because when you have 2 and 2 here, you actually have a greatest common factor of 2. And in the beginning, we never even could factor out a greatest common factor. So that wouldn't make sense. So this is not gonna work out. That's gone. Try 1, not even gonna go with it. Try number 2, you couldn't even switch the numbers around. You switch 2 and 2, you still get the 2 and 2 there. So guess what this means? 2 and 2 is out. Well, for 2 and 3 at that, right? We still could try 1 and 6. So now I'll just keep everything the same color. Now we can try 2, 3 with 1 and 4. So 2x minus 1 and 3x minus 4. If I FOIL that out, I get 6x squared negative 8x minus 3. It should be w, but whatever, it's the same thing. So I try 2, 3, 1, and 4. I get 6x squared negative 8x. I'll just write it out. Negative 8x minus 3x plus 4. And we get 6x squared minus 11x plus 4. Same thing, only thing it should be w. Checks out, guess what? Got it on the second try. Okay. Hey, look at that. That's all it takes. A little bit of practice. 4, same thing. Factors of 3, lucky us, 1 and 3. Factors of 8, 1 and 8, 2 and 4. Ready for the setup? Plus minus means that exactly. Plus minus. And factors of 3, 1 and 3. I'll have a 1x here and a 3x there. And which ones are going to get me to 2? Now, we can always try our trick out. Choose the last factors always first. Why not? 2 and 4, I'll put a 2 here. I'll put a 4 there. Now let's FOIL. 3x squared minus 4x plus 6x minus 8. And again, it should be z, but I'm using x, whichever. You get 3x squared plus 2x minus 8. Is this the same exact thing? 3x squared plus 2x minus 8, 3z squared plus 2z minus 8. And they are exactly the same. So it all checks out. And we get it on the first try. Factoring's easy, right? Look at that. Moving on. All right. We come across one of these jumbled up trinomials, you must rewrite it in proper form. 7p minus 15 plus 2p squared, we will rewrite as 2p squared plus 7p minus 15. It's now in proper form, highest power to lowest power to constant. And list the factors of 2, 1 and 2. List the factors of 15, 1 and 15, 3 and 5. Okay, we're ready to set up to factor. And you have plus minus, which means exactly that. Plus and minus. Okay, and these problems, well, our life is really easy because we have 1 and 2, factors of 2. So I'll have, and I'll do the right variable this time. It's a p. P and 2p. And then let's try our trick. Let's go ahead and choose the bottom 2, 3 and 5. I'll put 3 here. I'll put 5 there. Now let's FOIL. 2p squared negative 5p plus 6p minus 15. I get 2p squared plus p, 1p, minus 15. Not what we're looking for. Our middle term should be 7p. So try 1, didn't work. Try 2. Easiest fix is to flip the numbers. Let's go ahead and do that. And I'll make everything the same color on this one. We're just flipping the numbers. P plus 5 and 2p minus 3. Let's see how that works out. Check. 2p squared minus 3p plus 10p minus 15. 2p squared plus 7p minus 15. Is that what we are looking for? And the answer is yes, that's exactly what we're looking for. So we get the answer on the second try using the number flip. Okay, keep going. All right, once again, we get a jumbled mess. Rewrite highest power to lowest power. 6t cubed plus 7t squared plus 2t, highest power to lowest power. And then, this is not the proper form that we're used to. There is a cube in here, which means, can we get it to the proper format? And the answer is yes, because there is a common factor of t. So we take out the common factor of t, and that leaves me with 6t squared plus 7t plus 2. And now this is in its proper format, which means we can go ahead and factor it. List all the factors of 6. 1, 6, 2, 3. Factors of 2. Life is easy. 1, 2. Set up to factor, but do not forget that common factor of t that we took out. And also look at your signs. Plus plus means you'll have plus plus. Okay. And now what's going to work? Do we go 2 and 3, 1 and 2? Do we do this trick? 2 and 3. I'll put a 2t. Got to do the right variable. 2t, 3t. And then for 1 and 2, I'll put 1 here and 2 there. And let's check. I'm going to leave the t alone. I'm just foiling these two. 6t squared plus 4t plus 3t plus 2. 6t squared plus 7t plus 2. Does this look like the inside of that? It sure does, which means we are good and we get our answer on the first try. Seven, like all the others, rearrange highest power to lowest power. 6w squared plus 21w minus 45. Rearrange from highest to lowest. Now list your factors. 1, 6, 2, 3. 45. Oof. 1 and 45, 3 and 15, 4, no, 5, yes, 5 and 9. And I think that is it. 6, 7, 8, 9. Nope, we're good. We have our factors listed. Ooh, actually, I didn't see this. 6, 21, and 45 all have a greatest common factor of 3. So let's go ahead and pump the brakes really fast. And if I factor out a 3, I'll get w squared plus, not w squared, 2w squared plus 7w minus 15. A lot easier to factor now. Not so many big numbers to handle. Where you list the factors of 2, 1 and 2, list the factors of 15, 1 and 15, 3 and 5. That looks so much easier to deal with. We are ready to factor. Don't forget that common factor of 3 that you took out. You have plus minus, which means exactly that. Plus minus. Now, who's going to work? Well, we only have 1 and 2, thank goodness. So the variable's w. I got it. W, 2w. And then, do we go our trick, 1 and 15 or 3 and 5? Let's try our trick out, 3 and 5. I'll put a 3 here and a 5 there, and let's check our work. And remember, just FOIL these two. Don't worry about the 3. 2w squared minus 5w plus 6w minus 15. 2w squared plus w minus 15 is not what we're looking for. We're looking for 7w. So one of the easiest fixes, switch the numbers. 5 and 3 will switch. So try number 1 did not work. We move on to try number 2. Don't forget the 3 on the outside, and I'll just make it all the same color. W plus 5 now we switch them. And 2w minus 3. Check your work. W squared minus 3w plus 10w minus 15. W squared plus 7w minus 15. And we check out. Check, check. I keep forgetting my 2. And it looks the same. Okay. So we have our answer on the second try. 8, another mess. Rearrange highest power to lowest power. 6y to the 4th minus y cubed minus 2y squared. Now you notice that we have y to the 4th, y cubed, y squared. We can take out the lowest power of y squared. You get 6y squared minus y minus 2. We are ready to factor. Factors of 6, 1, 6, 2, 3. Factors of 2, 1 and 2. Get ready to factor, and do not forget the y squared that we took out. And now look at your signs. Minus minus means plus minus. And let's try our trick. Let's see. 2 and 3, 2x, 3x, and lucky for us, there's only 1 and 2 there. I'll put 1 there, I'll put 2 there. And it should be a y. There. Now it's a y. Check. 6y squared minus 4y. 6y squared minus 4y plus 3y minus 2 gives me 6y squared minus y minus 2. Check, check. Good to go. Good on the first try. Okay. And then number 9. All right. Last one for these. Woo. So first thing we see is that there's a negative in front, which we don't want. We want it to be positive, so we know we can factor out a negative number. But also look, 8, 12, 8. You can take out a 4, and we're going to take out a negative 4. And if I factor out a negative 4, you'll get 2a squared minus 3a minus 2. So the negative affects all the terms. Okay. Which means we are now ready to find all the factors. Lucky for us, factors of 2 are 1 and 2. Man, this couldn't be any greater. Ready to factor, and that negative 4 stays out front. Follow your signs. Minus minus means plus minus, and well, we only get to choose 1 and 2, and there's an a here, so I need to put a. So I'll put a and 2a. And then we have a 1 and 2 here. So I'm going to put 2 here and 1 there. Now let's check. 2a squared minus a plus 4a minus 2. 2a squared plus 3a minus 2. Close. We have a positive 3a. We're looking for a negative 3a. So one other easy fix is to switch the signs. So option 1 didn't work. So we go to option 2, and I get negative 4. Don't forget that. Keep everything the same color now, and all I'm doing is the sign switch. A minus 2 and 2a plus 1. And that should do it. Check, of course. 2a squared plus a minus 4a minus 2. 2a squared minus 3a minus 2. And we get what we want. Check there, check there. Same exact thing. Same exact trinomial. It checks out, and there's our answer. Whew. That is factoring trinomials using the guess and test method. So you want to get it down into 1 or 2 tries. Not 8, 20, 30 tries. Even though that's a good learning process, but you can get away with the little tricks. Okay. Last page, I promise to make it fast. This is probably going on over an hour now. That's fine. This is factoring. It's one of the fun F words, okay? And next is something called factoring a difference of difference of squares. So the terms must be 2 perfect squares. So if you are given the statement a squared minus b squared, where a and b are perfect squares, then it will always factor out to a plus b, a minus b, no matter what, as long as they're perfect squares. Or even a minus b, or a minus b, a plus b. Okay. And how do you know if it's a perfect square? Well, know your squares. 1 squared, 2 squared, 3 squared, 4 squared, all the way up to 15 squared or 30 squared or 100 squared. Just know what a perfect square looks like. Okay. So let's go ahead and look at these perfect square binomials. And first thing we see is that y squared is a perfect square and 25 is a perfect square. So the only way to factor this is to use the formula above. This will factor to y plus 5, y minus 5. That's it. Nothing else to it. No more to think about on that. 5 times 5 is 25. Y times y is y squared. And there will be no middle term. Okay, not bad, right? That's it. Like I said, simple. These are the easy ones. 2. 49 is a perfect square. S squared is a perfect square. 4 is a perfect square. T to the 4th is a perfect square. So this will factor to 7s minus 2t squared times 7s plus 2t squared. That's it. If you don't believe me, FOIL it out. Three, 18 and 2 are not perfect squares, but we do notice that there is a greatest common factor here. 18 and 2, you can factor a 2 out. W squared, there's no W there. But then Z and Z, we can factor out a 2 z. So if we factor out a 2z from 18w squared z is 9w squared, minus 2z from 2z is 1. Where now you notice 9w squared is a perfect square and 1 is a perfect square. And the reason 1 is a perfect square is because 1 squared is 1. Okay, which means we can now factor this difference of squares. Do not forget what we factored out. And this will factor to 3w plus 1, 3w minus 1. That's it. Four, an easy one. That squared, that's a perfect square, right? So we say a plus, a minus, and all we have to say is what number squared gives me 64? And that is 8 and 8 and done. Moving on. 25 is a perfect square. Q squared is a perfect square. 49 is a perfect square. W is a perfect square. So you're going to get plus, minus, and what number squared gives me 25? That would be 5Q. 5Q. What number squared gives me 49? That would be 7W, 7W. Done. That's it. Last one for these. 98 and 50 are not perfect squares, but you realize that you can factor out a 2. And then m cubed and m, you can take out an m. And then n and n, you can factor out an n. And if you factor out a 2mn from 98, you will get 49m squared. Minus 2mn from 50 is just, from 50mn is 25. And now, 49m squared is a perfect square. 25 is a perfect square. Bring down your greatest common factor. And what number squared gives me 49m squared? Would be 7m. Minus what number squared gives me 25? 5. And 7m plus 5. That's it. Those ones are the fun ones to factor, right? Nothing to it. Last page. All we're looking at is can it be factored or not? And if you are given something called the sum of squares, which is the form of two perfect squares adding each other, a squared plus b squared, then it is not factorable. That's it, not factorable. So if you see the sum of two squares, automatically you just write not factorable, or we can also write the word prime. So factor the binomials if possible. Well, first, you have p squared, which is a perfect square. 9 is a perfect square, and they're connected by subtraction, which means this is a difference of squares, which is what we were factoring on the last page. So this means this can factor to p plus 3, p minus 3. That's it. Next, you have p squared and 9, but they're connected by addition. This is a sum of squares. Ooh. And what we just saw above really fast was sum of squares are not factorable. Or we call it prime. Next, t squared minus 144. That's a difference of squares, which can be factored to t minus 12, t plus 12. That's it. 4, t squared 144. Those are perfect squares, but they're being added. This is another sum of squares, which is not factorable, or we call it prime. And I think that finishes our factoring strategies. Take it slow, take your time, but don't take too long. And that's how you factor, everybody, in a nutshell. All right, that is it. That was part 2. Till the next time.